VITA 100 covers a lot of other standards from VITA, and it's designed to essentially move forward with the technology that's been used in avionics and military applications, rugged environments. So to start with, where do we stand with the standards process for VITA 100? Dan, could you fill us in?
So we're about a year into the actual development of the standards after a multi-year task team looked at what needed to happen to build out those standards. What the group has done is they've really developed a nice set of individual standards and a taxonomy to place the things that we've learned over time need to exist in a very ordered grouping. And under the leadership of Steve DeVore and the recruitment of Steve DeVore, we've started to turn on some of those individual working groups to start to fill in those areas. The one that's focused on the base standard and the connector system and the mechanical have been going on for about a year. The ones with system management have just started up in this year, and we're going to start to see even others start to form to the timeline that has been defined.
Mark, could you tell us how someone could get involved with the standards process?
Sure. As Dan and you pointed out, it's a suite of documents that are being created. So there's a lot of work to be done. If you're a VITA member, or if you're not a VITA member, I'd encourage you to join VITA and help us to write this. You can be a real contributor to the creation of our future architecture around VITA 100. If your interest is in the kind of the system architecture, if your interest is in system management, if your interests are thermal and mechanicals, the electricals, signal integrity is a great place where if there's some experts out there that want to really kind of contribute to the whole, signal integrity would be a great document to work on and is desperately needed. So yeah, there's plenty of opportunity. Just contact VITA and join, and then start to participate.
Well, I know getting started with this is developing the standards, and they're coming together very quickly, but obviously you need some hardware to get started as well. And at the very beginning, one of the things is connectors. Mike, could you tell us where we stand with this with respect to standards and availability?
Yeah, so the VITA 100.30 connector is a new connector. It's being tooled. So our target is to have testable production grade product by the end of the year. And then do qualification the first half of 2026. So that's what we're working toward. I mean, I would say a lot of the standards, including the connector, we're working on getting all the drafts laid out, getting them finalized and through balloting by the end of this year. But the hardware and that implementation and testing behind it would be required before it goes to a full ANSI published standard. But so that's our target. 4 pairs first, which feeds the 1-inch slot profile, 6 pair connectors a few months beyond that schedule.
In terms of hardware built on this, how far out do we see that?
So I would project that we'll start seeing prototype hardware, in the next 1 to 2 years as people start to put together and start to test and start to understand what these components look like on the market. I would literally think that, with the standard maturization and the accreditation to ANSI, followed on by the time it's going to take to get acceptance into programs and into customers, that you're probably more looking at deployments or acquisition type things to fall down in the next 5 years is probably where you'll see that start to come into full fruition.
I can add, though, that I know what Elma is doing with regards to preparing for the era of VITA 100, and I have to believe that other companies are doing the same. We want to hit the ground running, and we want to be able to provide backplanes and infrastructure and maybe even some payloads when the time is right, when the standards are set, when the testing is done. Elma wants to be ready to provide those components.
One thing I want to talk a little bit about is how quickly and extensive the VITA 100 standards have come about. Dan, could you talk a little bit about this? Because from my perspective, it's been a lot quicker than some of the things that have happened in the past.
Yeah, I think in general, I think the advent of OpenVPX, its success in the industry, and the natural successes that the MOSA initiative has done to the industry has really become an education for the masses of suppliers that play in this space. And I think, in the early days of OpenVPX, what does a system architecture look like? A lot of the suppliers that participated in there maybe weren't all in the know of some of the needs of the integrators. And what we've really seen happen over the last 10 years is you see a lot of the integrators and the suppliers communicating in these open standards organizations, and that education is allowing them to more, quicker get to quicker decisions on consensus of what we need to do to move forward. And it's just enabling a community knowledge as to how to get these things done such that they are actually useful to the integrator environment. And I think a lot of that learning and a lot of that demonstrable in the lab findings of putting together these systems over the last 10 to 15 years is really why you're seeing everyone come together to solve the common problems or the common needs that exist beyond what OpenVPX can provide today.
So I'll add to what Dan said in that we also benefited from a 2-year study period where not only members from industry, but also the integrator community, the folks within the VITA, also within the SOSA community, and even in the government participated in that study. So we wanted to make sure that we documented what we wanted this next generation architecture to really look like. And so we had a pretty good framework of how we wanted to approach this standards activity before day one. And that has really helped us to kind of accelerate, hit the ground running, so to speak.
Well, I know we're, sort of at the very beginning, but looking into your crystal ball, where do you think we're going to be headed with VITA 100? Are we going to be expanding the areas that it's be applicable to? Are we going to be seeing higher performance systems? Whatever. I'll start with Dan.
So I think most assuredly we're going to see higher performance systems due to overcoming some of the challenges we have with VPX on the power, the I/O, the thermal management, and in some cases the physical size of the 3U small form factor. So certainly we'll be able to better stay at pace with the technology of the component vendors and the interfaces between them. I also think that with updates to things in the management subsystem, we're going to start to address in a standard way some of the necessary dynamic reconfiguration that allows us to have more resilient systems and allows us to have more configurable systems, which is what one of the MOSA initiatives really is about. How do you maintain and update your subsystem by changing boards and sort of reconfiguring as quickly as you can?
So I'm going to go out on a limb and make an actual prediction. So we'll come back in a couple of years and see if this is going to be reality. But one of those limitations that we have with VPX, 3U VPX in particular, is switching. You can really only switch fully a limited number of slots. And we're oftentimes, if you're making a larger system, forced to put multiple switches into the system. And that is really kind of suboptimal. It's bulky, it takes up power, and it hinders the architecture. If you want an all-to-all communication, you're often limited in having to break things up into domains. I think the first successful VITA 100 products are going to be switches, and they're going to go into hybrid VITA 100 VITA 65 systems, maybe even just a VITA 100 switch with VITA 65 payloads hanging off of it. It's going to just really kind of unshackle us, with regards to the networking inside the system. So that's my prediction.
actually building off what Mark's talking about with these high density switches, that's the reason we're doing a 6-pair connector. So it's taller, deeper onto a plug-in card than OpenVPX today. It fits into 1.2-inch slot pitch. But one of the benefits of having a wafer-based connector is we're integrating AC coupling caps into the wafers. So we're not only freeing up board space, plug-in card space, we're also improving signal integrity in those channels as well. We've also, on our roadmap, we've got an optical transceiver package that can fit on a multi-gig wafer. So we're looking at how we can integrate optics into the optical conversion, the EO conversion into the connector, rather than having to do that on a card. So if we can save some real estate on a plug-in card, that gives a lot more functionality and fits within those sizes. And one other thing on the 6-pair is essentially at a 1.2-inch pitch, you have more room for optics. So if you have a switch with an optical, a half-size optical module on the end, we can actually get 4 MTs on there versus 3 MTs today. So we're building that capability around those switches, putting a lot more into the space that we have allocated.
Well, thanks everybody for giving us a little more insight into VITA 100. I look forward to talking to you about it in the future.